In this problem, we're told that testing for a disease can be made more efficient by combining samples. So if we have samples from 4 people, we combine them into one mixture, and that mixture tests negative, then all 4 samples are negative. So if we had a negative, a negative, a negative, and a negative, then those 4 together are going to give us a negative result for the sample. If we had any positive sample within that group of 4, so if I had positive, negative, 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 this is going to result in a positive result. If they were all positive, we're going to get a positive result. So the only way to get a negative result is for all of the samples, the individual samples, to be negative. So what we want to do is take a group of 4. If it's very unlikely for any individual to be positive, then we're hoping that most of the time we have 4 negatives and we're going to get the sample is negative. And now I've only used one test on 4 individuals. So we want to see, is that a good strategy? Are we going to be saving money? Or are we often going to have to go back and if we get a positive result, then go back and retest all 4 individuals, and now we've used 5 tests for 4 people instead of just 1 test for 4 people. So how do we calculate this? Well, we're told the probability of a single sample testing positive is 0.1. So I'm going to write that down. Probability of positive is 0.1 or 10%. So that means the probability of an individual being negative is 1 minus 0.1, which is 0.9. We want to find the probability of a positive result. So that means one of these scenarios where we have at least one positive sample within the group of 4. So we want to calculate what is the probability of a positive result for the entire sample, the entire mixture of 4. So what is the probability of getting a positive result for 4 samples mixed together? And what we would be saying here is we're looking for the probability of at least one individual being positive. So when we're calculating the probability of at least one, I don't want to have to figure out all the different ways we could have at least one positive. So what we're going to do is instead of that, we're going to calculate this by saying, what's the opposite? And then subtracting from 1. So probability of at least one individual being positive is the same thing as 1 minus the probability of all being negative. So, because we are assuming this is testing with independence, so that means that it wouldn't be a family of 4 all coming in and having their samples mixed together, because then we'll change the likelihood of getting a positive result. So one person being positive might make it more likely for a second person to be positive. So we're assuming that these are independent, and probability of getting the first one negative is going to be 0.09, or 0.9, sorry, not 0.09. So then the probability of the second one being positive is also 0.9, and the third one, and the fourth one. So I'll put this into the calculator as 1 minus 0.9 to the power of 4. And I get 0.3439. So that's the probability of my positive result. Now, in the next part, it's going to ask, is this probability low enough so that further testing is rarely necessary? And we're going to say no, because we're saying 34% of the time we're getting a positive result. So we're often going to have to go back a little bit more than a third of the time, go back and do 4 more tests. So we'd be better off not doing this mixture. So we would need the probability of getting a positive result for an individual to be a lot lower before this was a good idea and a cost-saving measure. So that's how you do that problem.